Here we'll talk about how to take the derivative of a product of functions. So we have something like f times g prime. And our instinct may be to take the derivative of each and multiply them, but that's actually very wrong. That's not what we're going to do. And I'm not going to outright derive the product rule here. Instead, I'll just simply state it. And if you're curious, you should look into it and figure out where this rule comes from. But it essentially says we take our first function times the derivative of the second plus the derivative of the first times the second. So we need to take the derivative of each function and multiply them by the other function without the derivative. So let's do a few examples. Here I have a function x squared e to the 3x. And for the product rule, we need a product. I have an x squared term, and I have an e to the 3x term. So we do have a product. The product rule says to just write down the first function. And then we're going to multiply by the derivative of the second. The derivative, we would bring the exponent down, and then e to the 3x. We then need to add. We're now going to take the derivative of the first function. We bring the exponent down and subtract 1 times the second function. So now we have our result. A little simplification just to make it look nicer. 3x squared e to the 3x plus 2x e to the 3x. You may also see this written as x e to the 3x times 3x plus 2, where we simply factor out that x e to the 3x, but that's not required. Either one of these two are perfectly acceptable. Let's do another one. This time I have an e to the x and a sine x. So we have our first function times the derivative of the second, and we know that the derivative of sine is cosine. We're then going to add the derivative of the first function. We know that the derivative of e to the x is just e to the x times the second function, which is sine x. So this is a perfectly acceptable form to write it in. You can also write it as e to the x cosine x plus sine x. Let's do another one. Cosine squared x. So you may once again want to just use our power rule, bring the exponent down and subtract 1. But once again, this is very wrong. This is a product and we have to treat it like one. Instead, I'm going to rewrite this as cosine x times cosine x. And then we can use our product rule. We write down the first function times the derivative of the second, and the derivative of cosine is negative sine, plus the derivative of the first function, which is negative sine, times cosine. And we can see that this is actually negative 2 sine x cosine x. So it definitely does not look like just 2 cosine x. In fact, the power rule is only used for polynomials, and cosine is not a polynomial. So we do have to use other methods. Now let's do one more that's a little more complicated. Here I have x cubed e to the 4x sine 2x. And so we're no longer just multiplying two things. In this case, we're multiplying three things. But we can still use the product rule. We do need to break it in two pieces, so we'll use x cubed e to the 4x together, and then sine of 2x is our second function. So our derivative says we write down the first function, x cubed e to the 4x, and then we multiply by the derivative of the second function. When we have sine and cosine, we need to move the 2 out, and the derivative of sine is cosine. We're then going to add the derivative of the first function, and this is where it gets a little bit tricky. We're going to now break this into two pieces, the x cubed piece and the e to the 4x piece. So that product says we would write down the first times the derivative of the second, which is 4e to the 4x. We would then need to add the second function, the derivative of the first, which would be 3x squared, times the second function, e to the 4x. And then that's now our derivative times our second function, sine of 2x. So this looks really complicated, but we're going to simplify it and make these types of problems a little bit easier in the future. This is now 2x cubed e to the 4x cosine 2x plus 4x cubed e to the 4x sine 2x plus 3x squared e to the 4x sine 2x. So the important thing to note here is we don't want to have to deal with this process every time, so let's try to see a shortcut. And there actually is one. You'll notice in this first function, we have the original, what we called the first function, times the derivative of sine. In my next one, I have an x cubed and a sine of 2x, and then I have the derivative of e. My last one has an e and a sine, and a derivative of x cubed. So essentially, whenever we have a multiple product, we're going to take the product of each term individually and multiply it by the other functions. So we take the derivative of one, multiply it by everything else, the derivative of the second, multiply it by everything else, and the derivative of the third, and multiply it by everything else.